Oh. All right. So let's look at our circuit here. Okay, the first wire is in, and it is pleasing to see. It's not perfect, but I think I'll work with it for now. Put the scraps like right here, the extra wire bits to the side, and this bit too. We are trying to make a nice looking circuit board because all I've been building recently is just rat nests. So hopefully this one will actually look somewhat decent. So there we go. We are done with one more NAND gate. After we're done with that one, we can go ahead and combine C and D, which I'm using S1 and S0 over here. So red, I actually misplaced a wire here, so we'll have to fix this one. Turns out we won't be needing as much as I thought, and just out. Straighten out the wire. And we're done. So this one is also wrong, so we will have to fix this as well by just grabbing this. We'll be chopping that part off and keeping just this part. We'll bend this downwards. Make sure this is still straight. There we go. Actually, let me fix that up a little bit. That kind of looks. That right there. And it's in. Okay. We can move on to combining C and D, which are both inverted. So we will be using black wires here, and we would like to combine them into one gate. So I'm thinking I will bring D down to over here, this gate right here, and by the way, the circuit's in the top left hand corner, so you can see exactly what I'm building here, which is a simple logic expression, and we're gonna be using NAND gates to build it. So I'm thinking I'm gonna bring D to the output first, actually, because it is a lot closer. I only need around 1, so I'll just be chopping a good amount off, and maybe a little bit more to here. Let's strip the wire. I will bend it using a plier before finally putting it to the correct slot. My hands are too big for this, but nevertheless, I think I'll use this slot here. And it's in. Perfect. Now I just need to connect the output from here into the input right here. So that requires like not much wire. Let's make a marking. Cool trick I found is that since the wire, you can make a little marking using your nail so you know where to cut exactly. And that's been helping me a lot to get the wire lengths correctly. If anyone's getting into breadboarding or circuiting, I think that's just mark it with your nail a little bit on the wire so you know the length to cut, so you can make neat cuts on your wiring so you know how to troubleshoot it later. And we can make it aesthetically pleasing and not a rat's nest, so that's always good. And after combining that, we would be combining AB, and that would be, let's see, AB, it would be this output here. We can combine this output and this output together into another NAND gate. So I'm going to be using white wires for this one, and I'm thinking I use this NAND gate right here because it's not too far away from both of them. So I would pull over my output from NAND gate. We would cut the wire here, strip off a part of it, and select all my waste real quick to here. Let's try to stay organized so we know where everything is. We will plug this right here into the first input of the NAND gate. Push it down, make sure it's flush with the board. Alright, that looks really nice actually. It's almost camouflage in there. And we can take our wire here and let's strip off a part of it so we can estimate the distance. Strip off a part of the wire and you can plug it into the output here. That will run all the way into the input here. That's gonna take a bunch of wire, quite a bit. So let's take out the wiring. Let's bend it. Let's try to bend it 90 degrees there. So then we can try to like estimate how much we need to go. Another 90 degrees here. It has to hop over quite a few wires. So we will try to accommodate for that. By bending the wires towards just slightly above it so it can go over all the wires. Not this, but I think we can have a good estimate now. By plugging that side in. Okay, I see some adjustments I need to make. That's fairly simple. I just need to flatten this out. I mean, who doesn't like some neat wiring, right? It's aesthetically pleasing, and we don't have to worry about getting all the wires mixed up later when we're troubleshooting. So I think general rule of thumb is try to keep the circuit as neat as you possibly can, so it's a lot easier in the long run. But some people tend to go for speed instead of building the circuit nice and neat, and sometimes that results in a lot of troubleshooting afterwards. Or, I mean, if you're lucky, then the circuit works perfectly fine, but it still looks like a rat's nest. So, you know, I think keeping the circuit nice and clean is a good habit, and definitely useful for later on when circuits get even more complicated. So you can actually keep track of what's actually going on instead of spending 30 minutes looking and still having no idea of what is happening on the board, you know? So we'll mark it like right here, and that's like the spot where it needs to like turn downwards. And we'll just cut the wire like here, and we can strip out a tiny piece right here. Throw the wire there, bend this one downwards as well, and I think we might have it. Let's see. Does it plug in well? Hey, that's not too bad. We'll just clean it up a little bit and it'll be okay. So clean it up here. Strip out a little bit there. We don't need too much wiring. And then we'll be finishing up by straightening out this part of the wire. Make sure that it's not so bendy. There we go. The wire is in, and it is very straight, and all right. The wire is in and it's flush with the board. This wire is done. Okay. So now we're done with connecting those two together. The output would be going into another NAND gate. So let's grab our wires and get ready for another NAND gate. This one, I think I will put it into this NAND gate right here because it would be the closest. Or actually, let's do a different NAND gate for now. So we'll take B and C D and C, which is this, and inverted here, this output, and A inverted A. So a inverted A would be these two outputs here, and we'll put those into a NAND gate first before we consider about the final NAND gate that'll combine everything together. So by taking this apart, we can grab this wire, we would put it right here, and I think I would like to drag it out a little bit. So what I'm going to do is grab this, make sure that's bent, and then bend it upwards. So make sure everything's in a straight line, bending it upwards, and then bending it forwards, or finally grabbing it again, bending it down, and then we'll bend it down, turn it to the right, and I think that's pretty good for now. Let's try to see if it is compatible. It does work, but I've realized a small issue I've made. I will just quickly fix that so it doesn't become an issue later on. And it's fixed. Okay, so let's try to plug this back in. Let's try to fix that up a little bit. I think it does need some improvement, so I'll redo that one by squishing it flat, and bend this down. Bend that up. That up. Bend that down. Bend it out again, and now we can connect it onto the board, and it is flush and perfectly on there. Okay, and now you can route this wire towards let's say over here. Over here would be the most ideal spot for it, I think. So by doing that, we will need to bend it again, this time inwards. So around right here, we would bend inwards, and then we would bend outwards again. So let's see if this will be right. Okay, it looks like I messed up a little bit, so we will try to fix that before we move on. Turns out I need to bend it a lot earlier. Inwards, we'll just do a little bit of like a staircase shape as we get closer. I think over here should be fine. A little bit more forward and more over here. Okay, I think that staircase shape should work great. I'll just place this back, and slightly missed it. That's okay. We can always flatten the wire and try again. Sometimes it gets kind of frustrating when you just like barely miss it, but that's okay. I mean, at least you get to try again here. You might not be able to in real life, you know? This wiring is generally very forgiving because you always get second chances. But we need to understand that it's very rare in life. You don't really get second chances. So we would just plug the wire in here. Drag out the wiring. Go over here. Before we can use it to plug into right here. Okay, I think I made a hard enough marking. Yep, okay, so we would, I think let's try to flatten it out before we keep going. I would grab this and we can take the wire off before trying to flatten this side again. We can try putting this one in by putting this in here. You see it's a little bit off, so we would just put off some more wire, strip it off, and have most there. Well, it's almost there, guys. Almost there. Just a little bit more. We would bend the wire just like this, and then bend it downwards. And we have a completed wire, maybe? Oh man. I would like to fix up this wire a little bit more, maybe. Although it is gonna have to be diagonal, which isn't the best, but I think that's all I can work with now. Diagonal, but okay, that works for me. I'll be just fixing up the wire a tiny bit. We have the wire. It is in to the board, and it looks all right in my opinion. Doesn't look the best, but at least it's not a rat's nest. Actually, I think it looks pretty good. you know, it gets a job done. It's clear where it's going to, so I think that gets a job done. All right, now we will continue by adding a very, very short wire here. It doesn't even span over one. It's just okay. I accidentally stripped off too much, so we would try again. This one we will just strip one side off. The other side. Go free. It needs to be even less than this, so I guess we're stripping off a little bit more. Okay, and we'll cut the legs of the wire shorter too to make it at least a little bit better. We have one singular bit of wire. This tiny piece is going to, if I can even grab it, my hands are a little bit too big. Okay, let's try to use this to put that in there. Okay, goes in just fine. Wiring is just like life, you know? Like, even if this small piece, if it wasn't there, then the entire circuit wouldn't work. Just like, you know, if you're just missing a little bit part of your life, then your life wouldn't be complete. So we need every single part for our life to be happy, and we, you know, live happily, I guess. So finally, we'll be connecting the last part of the circuit together, which will be a final NAND gate. So connecting the wire from here to the input, which will be over here, so very close. I won't just need a little bit of help. The wire stripper, and we cut it, and we strip a little bit of wire off, and we have it. We have the wire. We will connect it from here to the first input. Okay, right here, and we're done with that one. We have one last wire to plug in, or should I say two last wires, because one of them is going to be for the input, and the final one will be for our one output here, which will be connected to an LED. So all this to make one LED light up. Shows that sometimes you put in a lot of work and you don't really get back anything. So you have to appreciate the process, not just the result. And some really valuable lessons as circuiting is teaching us, huh? Like, you would think, oh, I'm just building a stupid project for my engineering class, but in there's a lot of lessons that you can learn. So really thought-provoking, I'd say. And I will bend the wire to how we desire it. We connect it here. We bend it over here. And finally, we'll finish up by bending it one last time and down, so we can get the wire stripper tiny bit of wire. Bend it straight. Downwards. Now all we have left to do is connect this one with this right over here. And the wire that's in the middle gets perfectly crossed over, and we have one of the final wires. We have one final one, which is going to be to an LED. This one is going to be a bit of a wrap because it has to wrap it on almost the entire board. So we would take our wire, bend it across, or actually we can just and it goes like over here. Follow the path to the LED, which we will be using Y0 this time. Or yeah, Y0 works just fine. So we'll be using Y0. Okay. Unfortunately, I cannot power it on and test it, but the wiring is done, so I will test it tomorrow and we will come back to let you know the results. And we will also be working on a NOR circuit, so something a little different. I don't have that much experience working with NOR, so this shall be interesting. I will plug it in here. Let's adjust that a little bit. So it's closer. And we'll be using Y0, so over here. And then we'll be turning it down and cutting it. And finally getting rid of that last itty cover of the wire and plug it into our Y0. And the circuit is done. It is done. We have it. Okay, yeah. I was gonna adjust it a little bit more, but I think that's okay. The circuit is, in my opinion, aesthetically pleasing. So I will be ending it here today, and I'll probably be seeing you guys back again tomorrow because I have another project to do. So that will be it for today, and I'll see you tomorrow.